Okay, so just looking at the top, when multiplying or dividing radicals, you can combine them if they have the same index. What that means is if you have square root of 2 times square root of 8, you get square root of 16. That's fine. Also, if you were to have like cubed root of 3 times cubed root of 9, you could say, okay, 3 times 9 is 27, and you could have cubed root of 27. So as long as it has the same index, you can like multiply those and just put them in the house together. Also, it's getting a little warm in here. Let me put on the air pod. Okay. Continue. Okay, also with the division, square root of 27 divided by square root of 3, as long as it has the same index, you can just divide those and get square root of 9. Sure, good. Okay, so looking at the first example, rationalizing the denominator to get rid of radicals in the denominator, multiply, okay, yada, yada, yada. Okay, what we're going to do for number 11 is we're going to actually just put these all together. These are both like square root. So we can do 5 times 9 is 45. And then we're going to put the rest of everything inside the house. So 8 times 10 is 80. X times x is x squared. And then y squared times y is y to the third power. Remember, if you're doing y squared times y, that would be like y times y times y. So just y squared. You technically like add the exponents. Okay, so now we have it set up like this. We have to see what we can get out of this radical here. So we're going to break this up into factors, 10 and 8, which were the originals, and 5 and 2. Let me get my notes over here. Oh, it's blurry. Okay, so now we're looking for pairs of numbers here that we can take out. So we have 2 and 2, and another 2 and 2. So taking that out of the house, we have 45 times 2 times 2. And then inside the house, we have 5, based on this. And then we have to deal with the variables. So we're going to have our x's and our y's. And then this would just be a 2 there. We don't write the 2, but 2 over 2, and then we'll have 3 over 2. So this will equal 1, and this will equal 1, remainder 1. So now what we do is we can take these out, and this is going to stay in the radical. So 45 times 2 is 90. 90 times 2 is 180, so I'm just going to write that as 180. We have an x and a y we're taking out. And then inside the house will be 5 and 1 y. And we're done. Are you serious right now? Okay. Continuing. Okay, now moving over to number 12, focus. It looks like there was a little error here. This is supposed to be a multiplication symbol. So we have the same index here, so we can combine this and put it into the same root. So we have cubed root, and I'm just going to leave these separate because I'm going to have to break them up into smaller factors anyway. Okay, so from here, I'm just going to break it up into the smallest factors. 9 and 2, 3 and 3. For 84, IDK, maybe 242. Okay, 242. Okay, so it's cubed root, so I'm looking for 3 of a kind that I can take out. So it looks like there's 3 3s. So I can take that out. And then there's 3 2s. So we can take that out. And then there's just 1 7 left over. Cool. So that would be still in the house. So 3 times 2 is 6. Then we have cubed root of 7. And that's our answer. Make sure it's clear that this is here. Okay, we good? Okay, next problem. Over here, number 13. Okay, so we have fourth root here. They're both fourth roots, so I'm going to combine these two. 2 times 3 would be 6. I can put those together. And then inside the house, I'll have 8 times 2 is 16. X to the third times x to the fifth would be x to the 8. And then y to the second times y to the second would be y to the fourth. Okay, so I'm going to deal with things separately. The number first, breaking that up. Okay, so because it's fourth root, I'm looking for 4 of a kind. And there are definitely 4 2's here as the smallest factor. So taking that outside the house, I'm going to do 6 times 2 outside. And then inside at this point, I would just have these variables, which I need to do this whole thing. Oh wait, x and y. And then 8 over 4 and 4 over 4. So this would be 2 without any remainder, and this would be 1 without any remainder. So literally everything's coming out. Okay, so 6 times 2 is 12. And then we are left with x squared and y. Okay. Got it? Am I going too fast, too slow? I don't know. Okay, next. Oh, so some people are still writing. Okay, 14. Just continuing. A little bit of a different setup since this is in the denominator. We can't have a radical in a denominator, but we're going to see if we can simplify this first before we deal with it. So just focusing on this radical at this point, it's a square root here. Breaking this up into factors. Okay. We can take 2 2's out. So right here, just making sure I don't forget about that. 2 square root of something. It's going to have 1 2 left so far. Then as far as the x squared and y, 2 over 2, 5 over 2, this will be 1, and this will be 2, remainder 1. Okay, so based on that, 4 over 2, 1x, 2y's, square root of 2y. Okay, did everybody follow that so far? There's still one more step that we need to take. So we simplified this, which is great, but this is what we have as our solution so far, and we can't have a radical as a denominator. So what we do to get rid of it is we multiply like this. So we multiply by essentially 1, but in multiplying this by this, we get rid of the radical as a denominator. So rewriting this. So we get 2xy squared times square root of 2y times square root of 2y is just going to be 2y. rewriting it again. Combining like terms here, 2 times 2 is 4, x, y to the third power. And last but not least, the 4 divided by 4 is just going to cancel to 1. So our answer then is this. Here, one on top of the other. That's cool. We just have to do them separately. It's just a square root. Whoa. Okay. So we have A and B. 9/2 and 5/2. So that would be 4 remainder 1 and 2 remainder 1. We have lots of room at the bottom too, so I'm just going to go down here. Okay, so from here, I can take out a to the 4th power and just have an a inside, and then b to the 2nd power and just have a b inside the radical. We're getting somewhere. Then from here, I can't have that square root as a denominator, so I'm multiplying by square root of b over square root of b.
Can you slow down?
Sure. Thanks. And then, ready? Okay. Next. Now we'll have, and we're leaving room for that problem. Going down. A to the 4th square root of ab over b squared times b. And b squared times b is just b to the 3rd power. We're down there. Okay. The next one's a challenge one. I didn't put any like this on the homework. Are you ready to see the challenge one or no? Let's just do it. Okay. Next one. Next one's weird. Okay. We have 3/5 root over 5th root of, and I'm breaking up the 4y into 2 times 2 times y. There isn't any like this on your homework, but just so you can see like an even more challenging one and how you'd solve it. So for this, what you're trying to do is get rid of the radical as a denominator, but how we're going to do it is kind of interesting. We are going to multiply by essentially 1, like the same thing over the same thing. But the way we're going to do it is we need something that will simplify 5th root. So the way to simplify 5th root is if I had 5 2's multiplied by each other, I could take the 5th root of that. So if I added 3 more 2's over here, then the 5th root of all that would just be 2. And so we need also 4 more 5's, or 4 more y's. So if we had y to the 5th power, we could take the 5th root and it would be y. And we're multiplying by 1, so it's just like the same thing on top. Okay, so what happens here is this times this just becomes 2y. Because the 5th root of all that, you take 1 2 out and 1 5. And then as far as the numerator goes, 3 times 2 times 2 times 2 would be 8 times 3, 24. So the numerator becomes 24y to the 4th over 2y.
Move it down a little bit.
Yeah. And that's it for today. Okay, so the homework assignment on Schoology is up, so you can get a laptop, do the homework on Schoology. While you're doing that, I'll also be posting this week's Khan Academy, so if you finish it pretty quickly, then you can jump on and start this week's Khan Academy. So, okay, you can get up, get a laptop, get started on your homework.